take over.
Thank you, Erico. All right. So in this talk, we're going to describe two different projects, Jazzcarta projects, for which we chose Pyramid as the platform. Both those projects had a requirement to handle complex permissions, but the details of the projects were rather different and led us to somewhat different solutions. So I'm going to describe the first project here first before we dive into the technical stuff. So the first project, the Better Evidence Program, was a project for Ariadne Labs, which is a joint center for health systems innovation at Brigham and Women's Hospital in Boston. It's a big hospital in Boston, jointly between the hospital and the Harvard T.H. Chan School of Public Health. The goal of Ariadne Labs is to design and scale health system solutions that can produce better care. It was founded by a fairly famous surgeon and Harvard professor and best-selling author, Atul Gawande. You see a picture of him there in the middle of the homepage. Some of you might have heard that name because he writes for the New Yorker magazine, and he was also recently named as a member of Joe Biden's COVID-19 transition advisory board. So very excited that science is coming back into prominence in the US, federal level anyway. So the Better Evidence Program is one of Ariadne's programs, and it provides free subscriptions to digital tools to practitioners in developing countries. So the up-to-date decision support resource is an example of such a digital tool, and it is the subscription that is currently offered, although additional ones are planned in the future. Up-to-date is typically a fairly expensive subscription. It costs $520 US per year, and that is many times the cost of what people spend on healthcare in the settings of these practitioners that are applying for donated subscriptions. And that helps explain the willingness of the practitioners to go through a somewhat lengthy application process. So the Better Evidence website that we developed allows practitioners to apply for a donated subscription. And it also allows for the administrators to review the applications. It's a fairly long, complex 5-step application process that saves intermediate results at each step. First, you create an account, then fill out profile information, then describe the medical site that the user works at, then fill out a 30+ question application form, and finally, you get to write a short essay. So as I said, it's a somewhat lengthy process. This is a screenshot of the giant application form, just to emphasize the fact that it is rather long. We put a lot of effort into both presentation and widget choices on this form to make it as easy as possible for people to fill out. So the applicant users have a dashboard with dismissible notifications that shows any previous subscriptions and any previous application attempts. Then this is a review. Then there is a review system for admins. Here you see the screen for the application review work list. They can quickly scan new applications and accept or reject them. The keywords in the applicant statement are highlighted in the in yellow here in the little statements that go with the applications or essays. Admins can select from a menu of canned notification emails to send to the applicant, for example, explaining about how or why they should try again. Admins can also view all the application details by clicking on the application, and that includes a screen to show submission and approval history for the application, and they can leave internal notes on the applications for their colleagues or to remind themselves what's going on with the application. So medical sites have their own review screen. They're managed as separate objects since multiple applicants could work at the same medical site, of course. And new medical sites go through a review process also to make sure that they meet better evidence criteria. For example, for-profit sites are not allowed in the program. Sometimes applicants inadvertently create duplicate medical sites by using an incorrect name or spelling or switching the order of words. And when admins discover duplicates, they can be merged together with the original or correct medical site. You see the yellow icon on the right is the merge button. One more feature of the site, admins can also set different landing page messages to display to logged in versus anonymous users. Okay, now I'm going to turn it over to Jesse for a technical explanation of the site.
Hey, everybody. So let's see. So first, I'll just go into a brief discussion of why we chose Pyramid over other options. From the initial description of the project, we thought we were going to be building a very straightforward CRUD application. Applications we thought were likely to be in a standard format, and there would be just two categories of users. There'd be applicants who would submit and maybe edit applications, and then we'd have a fixed set of site administrators who would review the applications and apply some standard approval process. And since there's no reason to build admin UI if you don't need to, we thought it's going to be a great fit for Django. We'll do a couple of models and views, and we'll wire up the standard Django admin, and we'll be 90% of the way there. Of course, more conversations with the client followed, and the picture changed. So we had new requirements, and these included, in addition to the core Better Evidence administrative staff and a single product team, there would soon be multiple products with different applicants, applications, and more importantly, admin teams. This multi-product team model included a bunch of related feature requirements. So while some application questions would almost certainly be common to all products, many would not. Admins for product A need to review applications for their own product, but should not be able to see applications for other products. Workflow steps would likely vary between teams. So think simple Plone workflow versus some custom Byzantine workflow. Different teams might elect to do different things there. We needed to be ready to support permissions that varied by workflow state. Applicants can either sign up directly or in some cases be signed up by someone else at their institution. These are generally large hospitals or medical schools. And there was also some talk of a referral system. So it was becoming clear that this was no longer looking like a simple system. Specifically, we realized that Django really lacks the support for context-based permissions that we needed here. It's fine for granting someone global admin permissions that will apply in every context, but when you need to dictate that one person can take some action in a context, but not another context, the support in Django is lacking. And as Plone people, we really take all of this stuff for granted, and it's easy to forget that this is pretty fancy stuff, really. So our solution was based in Pyramid. So an interesting aspect of the project was that a lot of the difficult requirements were not immediate. They were coming soon, but not right now. So we wanted to be able to start simple and then add complexity when the requirements actually emerged, especially around these permission requirements. There's nothing more annoying for admins or users than a bunch of complex permission stuff you're not actually using. We also wanted an established opinionated pattern for wiring up permissions restrictions that didn't ooze into everything. And Pyramid was really a great fit in this regard. So I'll go over some aspects of the pieces and how they fit together. So what we do is create role records and relate them to both user records and optionally publisher records. So publishers and teams, as I described earlier, are the same concept. These are all just ordinary SQL alchemy models, but this gives us a really flexible way to categorize users into groups, which we can then associate with permissions. So in our project, admins could be either global for better evidence staff or team/publisher specific. Our role models have a property which constructs principal identifiers based on both a publisher ID and a level, like admin, for example. One or more of these roles can then get assigned to a user. So a quick reminder, a principal is just an identity for a user, and there are often more than one. For example, if I'm logged into a system, I'd likely be associated with an authenticated, an admin, and a jesse@email.com principal. And principals are also the way you model arbitrary groups. You'd assign a bunch of users the Plonista principal or whatever, and they could be treated as a group. That's basically how we're using them. We're just creating small publisher-specific groups. And then the pyramid authentication model provides a standard way of assembling and assigning a list of principals for a user through this group finder callback. In this example, we look up principals in the user's associated role records, which we saw on the last slide, and then just aggregate them all. The resulting set of principals is what gets associated with the user when they log or submit a request. And then the authorization half of this happens through ACLs, access control list. Pyramid lets you set up context-dependent permission by defining these ACLs. Critically for our project, we can programmatically determine the name for a principal to which we'll grant manage users permission, but only in the context of a specific publisher. So if we're in a part of the site under publisher 1, users with principal publisher 1 admin will get the manage users permission, but principal 2 admin won't. And then the final bit of glue for all of this in Pyramid is simple view decorators to declare permission restrictions. In the view, we just check for the manage users permission, and that's all we care about here. So all the detail about how the user was granted that permission is out of our hair. And as we add new teams and possibly new ways of assigning principals and mapping them to permissions, this view will be completely unaffected. It may change for other reasons, of course, but you really don't need to think about the permission system very much once it's set up. You just go about your business with your other changes, and that's pretty great. So now we're going to go back over to Sally, who's going to introduce our second case study, which is the Washington Trails Association.
Great, thanks, Jesse. So WTA, or the Washington Trails Association, provides extensive info about hikes in Washington State, in the northwest corner of the US. Jesse and I are going to be giving a talk tomorrow describing WTA and their 13-year-old Plone site. But this talk is about their volunteer management system. As part of their mission to protect Washington's trails and wild lands, they organized trail maintenance work parties. And in 1999, a volunteer created a system to manage work party signups. He wrote it in Perl, and it lasted until 2013. But by then they had pretty much outgrown it, and they needed a new volunteer management system. They hired Jez Carta to create the new system, and I'll just give you a quick tour of it. So WTA staff enter detailed information about the work parties in Salesforce, which is WTA's constituent relationship management system. And that information then gets displayed on the pyramid site through magic, which we're going to describe a little later. Volunteers can search for work parties and filter them by criteria such as when they're happening, the type of work party, the region it is in, features like bridge building or bring your family. And they can display the results of those filtered queries in a list like shown here, or display the results on a map as shown here. And handily, they can also display the results on a calendar. They can click on the work party title and see detailed information and have a button to sign up for it. So the information includes the location of the work party on a map and also detailed driving directions, pretty handy. The information includes what documents are required, for example, waivers that might need to be signed, and you can fill out and sign those documents through this volunteer management system. And finally, the Crew Corner tab provides a message board where the leaders of the work party and the members can communicate amongst themselves and arrange carpooling, that sort of thing. Volunteers can register for a work party by just as a guest, as an anonymous user on the site, but they can also log into their My Backpack account to register as a member of the site. My Backpack being essentially their member account, their member profile. We'll be talking more about that tomorrow. That is a Plone thing. Information about the crew members and leaders that have signed up is all captured in Salesforce, where the main management of these work parties is done by WTA staff. Okay, now I'm going to turn it over to Alec for a technical explanation of the site.
So I'm going to answer the question, why pyramid? Our decision-making process here was a little different than for better evidence. So our first thought was maybe we'd use Plone. The reason is that WTA's primary website was already a Plone site, so it would provide a seamless user experience. They have a ton of existing user accounts, and Plone has really great role-based access control. We already have Salesforce synchronization on their site for all sorts of existing content. And Jakarta had already developed some similar kind of event management booking system using collective workspace for another client. And we thought we might be able to reuse that. But when we looked a little deeper, we thought maybe not Plone. Doing a tightly coupled two-way sync to Salesforce is tricky and can be prone to errors. And for this application, we would really need the data to be updated essentially right away from Salesforce. And that made the synchronization we had in place that involves a lot of asynchronous operations not so useful. It was also very likely that we would see some performance issues, partly because of the Salesforce syncing, but also just because of general Plone stuff and things around collective.workspace, which would need its own Salesforce synchronization. And additionally, and perhaps the biggest concern from the client was that they didn't want to get further locked into a CMS platform that had a limited developer base. So our second thought was maybe we'd build the whole thing in Salesforce. We could create a dynamic React front end that talks directly to Salesforce via API. The volunteer info is something that really belongs in a CRM to begin with. They're already using Salesforce for all sorts of stuff. And there are a lot of Salesforce developers out there, and we were going to be working with Salesforce developers in any case. However, when we looked deeper, we thought maybe not Salesforce. The issues were that it would make it almost impossible to do SSO with the Plone site, which is where all of the user accounts were. There might be some ways to do it, but they would probably be pretty expensive. Making direct API requests to Salesforce can potentially cause performance problems, single points of failure, and can get very expensive, especially when running on a nonprofit account where you have potential monthly API request limits. There's also no good options for caching if we're doing direct client-side requests to Salesforce. and it was likely to have poor performance and reliability. So we went with a different solution, which is to take Pyramid, which is very Pythonic. Good Python developers are relatively easy to find. Even if you can't find Pyramid developers, most Python developers can get up to speed with a Pyramid app pretty quickly, so that eases maintainability. And then React as a front end, which is also widely used and widely known, and developers are easy to find. And so the architecture we chose looks like this. The flexible authorization system in Pyramid lets us do SSO to Plone using shared auth cookies. Registration data is cached in Redis on login and used to determine roles and permissions per user and per work party context. The work party data from Salesforce gets synced into an Elasticsearch for high performance queries. The resulting system is loosely coupled to both Plone and Salesforce, except when you're logging in and modifying work party registrations. The system ended up being extremely fast because all the data for work party searches and the primary work party views come straight out of Elasticsearch. So now we're going to look at some of the code. First, the authorization part. We've got what Pyramid calls a tween factory here that manages the SSO with the Plone site. If somebody visits this VMS site, which looks in a lot of ways like it's part of the Plone site, and clicks the login button, they'll go over to the Plone login form. And once they log in, they get redirected back to Pyramid with a JWT token in the query string. That JSON web token gets decoded by this tween here, which makes a call out to Salesforce with a user ID, and that returns contact details. And from that, we get everything we need to know about the user in Salesforce, the user's Salesforce contact record, as well as any existing registrations for work parties they or any of their dependents have. All of that contact data is stored in the session, and all the registration data is cached in Redis for making permission lookups. So this next bit is probably going to look very familiar to you from Jesse's portion a minute ago. We've got a group finder callback here. Users are pulled out of session, and they are added to a variety of group principles. There are some that are user specific, some that are based on a global Salesforce role. And then there are a number that are going to be specific to any work party registrations that they already have. They can be registered to specific work parties with a volunteer role or an assistant crew leader role or a crew leader role. All of their dependents also, they get groups representing all of their dependents so that they have permission to control any work party registrations that they for people that they're guardians for. Additionally, though it's not shown here in the code, there's a concept of land managers, who are people who have some control over a specific area where a work party is happening. So these are usually people that work for some sort of governmental entity, and they have certain rights to control or view information about a work party in their region. Here's the wiring. It's sort of some Pyramid boilerplate. It's quite simple. The group factory is added to the authentication policy. The tween factory is registered as part of the authorization policy. And then cookie-based sessions are set up, and that's all there is to it. Once we've got all that information, we can start defining ACLs. We have a work party object, which is the context for most operations in the system, and that has an ACL. And within that ACL, we assign permissions like view roster, participate, assist, report, search, lead. And those permissions are assigned based on the principles, which can be work party specific. And again, there are land manager specific ones as well. And then these permissions end up being wired to views using decorators, just like Jesse showed earlier. So in summary, we had two projects which were quite different in terms of user interactions, data models, backend storage. In the first one, the requirements for the sort of flexible permission structures that we're familiar with from Zope and Plone led us to choose Pyramid as the framework. In the second, performance concerns moved us away from Plone, and the need for flexible permissions and authorization again led us to Pyramid. In both cases, the ability to use relatively simple Python logic to map model attributes to roles and to declaratively configure access control was critical. We think the combination of performance and flexibility makes Pyramid stand out from other frameworks and makes it ideal for medium to large web applications with complex and evolving requirements. Thank you.
Awesome. Thanks, Alec and Jesse, and thank you all for watching the presentation. We've got some recommended resources here. I'm just going to leave this up for a few minutes for you while Erico turns to any questions that we can answer. And I encourage everybody to join us in the face-to-face session because it's really great to see your faces.
Exactly. Click the blue button below the video on Loudswarm, or just go on Slack. I'm going to post there the link right now. And it's there. So I would love to see you all in the face-to-face. Thank you, Sally. Thank you, Jess. Thank you, Alec. That was really good talk. We do not have questions on Slido and on Slack, so just jump into the face-to-face.
Thanks so much.
Thank you.
Thank you.
Bye.